Okay, hi, I'm Adam, and this is the video for Project 1. This is kind of the end product with everything set up, but I'm going to kind of redo everything and show you how it's done from the ground up. So I'm going to start in Workbench, drag over Fluent, and if you just double click this, it'll open up Space Claim, but so right click and Design Modeler. This will take just a couple seconds to open. Okay, we're just going to view normal to XY, and we're going to do a new sketch, set our units to millimeter, and I'm going to sketch a rectangle. Come over to dimensions. Ooh, that's not going to be good. You have to zoom in a little bit, or else it'll explode your dimensions sometimes. Yeah, this should be good. Just draw out your relative rectangle at 5, and then this has to be 50 times, so this will be 250 millimeters. And then to move it around like this, you hold Control and mouse 3, just like SolidWorks basically. And then we'll come back to modeling, select concepts, surfaces from sketch, apply, and generate. Okay, and that's it. You just have a rectangular surface. So we're going to go back to Workbench, and we'll start a mesh, which will also take a little bit to open up, but not to worry. Okay, so I'm just going to mesh the same way Dr. Ozbay does. So insert method, just select that. We'll start with this and make it quadrilateral, but then we need to insert some sizing. Oops, so hit edge select, control click. We'll start with the two sides, apply, and we'll do number of divisions. Let's just do 100. And hard behavior. And we'll generate that. It's going to make this weird turtle shell pattern. Okay, we're going to insert another, oops, not a contact sizing. Sizing. This time we're going to control click the top and bottom. Hopefully successfully, okay. And we're going to do again number of divisions. Let's make it 400 or 500. And generate. Then to finish off, we're going to, after it finishes meshing, we're just going to right click and surface mesh. Okay, or face mesh, yeah. Okay, generate that. Okay, and then it just kind of appears black, but it's because there's so many little rectangles and lines. So now that that's done, let's just quickly Let's name our different sides. So you have to select the edge again, press N. We'll call this inlet. We'll call this outlet. We'll call this upper wall. Call this lower wall. And yep, that's everything we need. Okay, so now we're gonna go back. We're just gonna update mesh. Honestly, don't really know when to update and when it automatically does it, but it's just good to be safe, you know. We'll just click double precision for Fluent, and let's start it up. So this is where you kind of have to play with the values, mostly with the viscosity, because depending on if it's too high or too low, you'll either not see anything, or else it'll develop too quickly and you won't be able to see any difference between the midpoint and the endpoint. So kind of just through a lot of trial and error, I figured out the values that work well for the Poiseuille and the Couette. So, okay, we'll make this laminar. Okay, so, oops, fluid. We'll make this air. We'll just set the density to 1. And okay, so for Poiseuille, this is actually the viscosity that I found works the best, 1e to the minus 5. So we'll change, create that, close. Just make sure this is the same thing. Okay. Now boundary conditions, this is where we kind of define everything that makes it either Poiseuille or Couette. If we just click here, we can see everything. So here, inlet is already as velocity inlet, which is what we want. So I'll hit edit, and I'm going to just set this to 8 meters per second. That's what I found kind of is the best for my case. So you can actually see everything happening. And then everything else, the wall should be stationary for now. As you can see, we'll make them moving for Couette, of course. For the outlet, I just have it set as pressure outlet. That should be fine. And reference values is, we're just going to compute from inlet. So that should all be fine. And okay, let us initialize calculate. Let's see, how many iterations did I do? I might not have specified it. Okay. Just to make it quick, I'll do 200 iterations. Yeah. There we go. Kasab would be proud. Oh, probably not really. It's taking a while. I also have my original ANSYS open, so that might be slowing it a bit. Let's just display vectors for now, just to make sure before we go into post. So you can see we really are getting the Poiseuille flow, and it is, you know, developing from left and right. You can kind of see some of the boundary layers too. Okay, so we'll come back to Workbench. Yeah, let's do update results. And let's open that. I'm just going to close the meshing because we're not going to need that anymore. Yeah, and the design modeler. Okay, so now we have here let us make a contour map of, let's see, symmetry. Make it velocity u. Let's try that. I'll just make a bit more contours. Okay, that still kind of looks bad, so let's make some more. Okay, that looks pretty smooth. So you can see it comes in, then boundary layer kind of develops across. Let's format this a little bit. So we'll go to the legend. We'll make it horizontal. Just make it variable. We'll make it float or fixed or float. And yeah, we don't need all that precision. You can change size, whatever. Okay, so let's see, my zoom is kind of blocking some stuff, but I'm just going to add a line. Call this midpoint because we need to find velocity profiles at the midpoint and the endpoint. So let's just do for the midpoint, it's going to be at 125 millimeters in the X. I believe this is X. Yep. And then in the Y, it's going to be from 0 to 5 millimeters. And we'll make, again, more samples. Apply. I'm just going to hide this for now. Okay, so yeah, we can see it's right here. This is in meters, so you have to divide by 1,000. There's probably a way to change it to millimeters, but that's fine for now. Now we'll add another line endpoint. For here, you can add 250 millimeters, but I'm going to make it just slightly less because if you make it all the way at the end on your chart, sometimes it gets a little weird just because it's at the limit. So if you make it just approaching the limit, so like a little bit less than the endpoint, you'll get a smooth curve. Otherwise, there might be like a little something weird at some of the endpoints. So I'm going to say 200. Oops. 249. Actually, we'll make it 2495. Make it even closer. Another 100 samples. Apply. Here we can see it at the end. And now we have to add a graph, but my zoom is blocking it. Okay. So here, if we come to chart, let's call it chart 1. It's going to be a plot. We'll call this velocity profiles. Data series. We'll have one at the midpoint, and we'll make another one at the end point. X-axis, velocity u, y-axis should just be y, I believe. I think this should be good. Ooh, I might not have specified. Okay, so yeah, so that's fine. So here we have velocity profiles. Let's see if we can name those. So let's just name this endpoint so it shows up on the graph. Okay, so here you can see red is the midpoint, which is the Poiseuille flow, and then blue is the endpoint. So if we go back to 3D viewer, let's turn this back on. So you can see this is where endpoint is, and this is where or this is midpoint and this is endpoint, and this is the velocity profiles at those locations. So now, okay, too much stuff open. Let's go back into Fluent, and I'm going to change some values to make a Couette flow. So first off, I'm gonna increase the viscosity, just because if it's too low, it's not actually going to make a linear velocity profile for some reason. For Couette flow, it's going to have some curves in it. So we'll just change that to, I believe that's what it was, 1 e to the minus 2. Yeah, that's how I have it here. Close that. Make sure, yeah, that's air. Okay, then we'll come back to boundary conditions. Inlet, this time, just going to be pressure inlet. We're not going to specify any velocity because, of course, it's all just going to be from the movement of the upper wall. So here we're going to move moving wall. I'm just going to make it 0.1 meters per second. That kind of makes a nice graph to look at. So reference values, we'll make sure that's inlet again. Let's do 200. Yeah, okay. Let's initialize and calculate. Let's doing this. Okay, calculation complete. Let's just display those vectors. Okay, yep, this is the Couette flow. We'll go back into post and it'll ask us to refresh, which is nice. So everything, all the series should be the same, and it'll update. Okay, let's go to 3D viewer. So yeah, have a nice little contour. You can copy that. You might want, because the velocity is smaller, you might want to increase your precision a little bit. Yeah, that's good. Go to chart viewer. So here, because we have the low viscosity, you can see it's just a straight line, and the midpoint and the endpoint are actually collinear. Let's see if I can show you. If I can hide, like, ooh, do I want to delete it? Okay, can I just hide this, or do I have to delete it? Okay, we'll delete it for science. If we delete endpoint, apply, yeah, you have the red one. So it just shows that they're on top of each other. Let me just make that back for the final one. Endpoint, yes. Okay. So those are the velocity profiles. Oh, and well, let me do the final. So we'll go back to, ooh, where is Fluent? Did it crash? I think it crashed. Okay, so, what? Okay, I'll have to launch Fluent again. So for the mixed flow, we're going to combine the moving top plate and the inlet velocity. Let's see if it saved anything. I should probably just delete or close one of my versions, but we're almost done. Okay. Let's see. Okay, so this is right, but we're going to decrease the viscosity again to 1 e to the minus 5. Go back to boundary conditions. Okay, so here we'll have to edit inlet to, oops, to make it, where is it? Velocity inlet. And yeah, I'll make it 8 meters per second again. And for the upper wall, okay, moving, and we're going to increase it to 8 meters per second. We'll call it okay. Let's make sure that is referenced from inlet. Okay, and we'll initialize and calculate. I probably could run even fewer iterations. It'd be fine, but it's too late now. Okay, we're at 70, 80. We got a tiny residual. Calculation complete. We'll go back into post. It'll update upstream. Okay, so 3D viewer, you can see the development of the mixed flow, and you can see it in your chart now. But if you want to find the actual values, you're just going to export. You just click export, and yeah, you can just name it something. It's going into the project folder, but you can browse and just select something. Just, I don't know, hit export, certain number. Oh, and then you need to do velocity U. And you should export it. It should be a CSV, and you can just open it in Excel and view everything like that. Okay, and that's it. That was my tutorial how you do everything in Fluent for Project 1. Thank you. Bye-bye.